Hello, this is John Rinaldi from Real Time Automation. I haven't made one of these videos in ages because I took a little trip. I took some time off, went to Italy, drank a lot of wine, drank a lot of the Italian coffee, ate a lot of good food. But now I'm back, and right away, what happens when I get back? I get upset. So today I want to talk about fallacies, mistruths, and conspiracies that I've been seeing. The first one I want to talk about is this thing called that there's an OT vendor conspiracy, that the OT vendors are trying to make a lot of money. Conspiracy. That the OT vendors have all gotten together and they've created all of this different technology so that they can make more money. Well, this is, it's an absolutely ridiculous statement. We've been doing industrial automation probably, since probably after post-war, we've been doing industrial automation. So the comparison is, I read this the other day, that Windows has everything works together, everything is really nice, everything, you can have different kinds of hardware, and there's no really problems, everything is just so easily to integrate, and that's not in automation because the vendors don't want it that way. That couldn't be further from the truth. In industrial automation, number one, we started long time ago before there was any standard hardware. We have different requirements. We have certain speed requirements we have to meet. We have different I/O requirements. We have to take this kind of sensor and digitize the floating point data. You have all these kind of weird different kinds of requirements. You have different kinds of cost requirements, different kinds of functional requirements. And all this stuff grew up over time as the technologies were changing. So no wonder we have different operating systems, different kind of hardware, different kinds of communications protocol, because we're trying to solve different kinds of problems. In the IT world, in the PC world, it was pretty much all the applications were really either gaming or standard business applications. There wasn't a whole lot of differences. Even gaming and business applications in PCs aren't that terribly different. You need a little faster hardware, you need better graphics and other stuff for the gaming applications. But that's an easier environment to make everything work. Definitely, there was absolutely no OT vendor conspiracy. And that red pen doesn't work, but you can see my X anyway. So let's talk about the next thing. The next thing that I talked about, that I heard about this when I got back from my trip, was this whole thing about that there's some kind of IT, OT collaboration going on, and this is going on great. Well, I have to tell you, it may be in a few places that IT and OT work together well, but a lot of places it just doesn't. I was talking to a cloud architect the other day, and he said, we deployed this incredibly nice system for OT to collect data, and four plants didn't use it. Well, one of them was not invented here. Well, we've got something that kind of does some of those things, and we're like really using our own system. And then another one said, well, we don't like it when corporate comes and pushes down, so we just kind of drag our feet on stuff. I mean, this happens all the time, that people don't like to change, and they don't like people coming in and saying, hey, you got to do it this way. So especially if IT people come in and say that we've got to do it this way. So I think this IT OT thing is mostly a myth, that people are willing to work together, because IT and OT have completely different goals. They work in different ways. They view the problem set differently. They have different sets of problems, number one, so that it's not something they work together on. I was in a plant not too long ago, and I looked at the cable, and both ends have two different labels. And I asked the guy, I said, why do we have two labels on the cable? And he goes, well, one's the IT label and one's the OT label. Really? You guys couldn't get together and even agree on how to label a frickin' cable? Come up with a number to put on a cable? No, we couldn't possibly agree on that. Well, geez, what hope is there? So, I don't know. A lot of people talk about this IT-OT collaboration. I just don't, for the most part, I don't see it happening. If I know operators, if they don't want to implement something, they're not. So if you want to do one of these projects where you want the OT, you want to deploy an OT system to collect data, you better get those people on board early, get them to support it. Otherwise, there's no hope. All right. Third thing that gets me irritated today is field network security. We've got to put field network security. We've got to put encryption on I/O messages. This is the most incredibly stupid thing I've ever heard. Why do we have to burden small OT devices, sensors and actuators, with doing encryption? I mean, it's absolutely ridiculous to me. That is not the way to secure the plant floor. Yes, we do need to secure the plant floor. Let's say that. I'm absolutely on that. But when we secure the plant floor, does it mean that we have to secure every message on the plant floor? Here's the advantage that we in OT have over IT. We can take some kind of manufacturing cell and we can secure all the access to it. That means that there's no open ports in here. There's no USBs. There's no way to get a USB. There's no Ethernet that you can, if you walk into this cell, you can't access it. Everything goes through some kind of secure box that makes sure that knows all of the messages that are going back and forth over this connection. So if that accounting always gets some production counts from the PLC in here. And so if somebody else on this network wants to get the production counts, it doesn't let them. It doesn't let accounting write to the PLC. It knows accounting needs these 3 tags, and that's all they ever get. If you have a smart box in here, you can prevent all that. Of course, you've got a lock cabinet with one laptop here, and that laptop can be used, if there's this problem in this cell, an electrician or a control engineer can go in there, use that laptop and access everything with no security. That's kind of your backup. But if you use an intelligent box here that looks at the messages and does message inspection and records messages that are valid and just says, hey, this message isn't supposed to be coming through here, then we can get rid of it. So this is totally different than the IT side. The IT people have no idea what the messages are going to be today. Who's starting a new application program? Who's going to a new website? They can't restrict messages. In OT, we can. So if we just restrict the message traffic into the cell, all of this stuff can operate without any crappy security protection that's going to slow things down, make this more complicated. And that's the really big problem I have with field network security. It makes it more difficult for the operations people to actually run the machines and make production. All right, number 4. The other thing I hear that I don't like is modeling. This is kind of thing that, modeling's all the rage. We got to have standard models. It's got to be just like a printer. When you go at home and you buy a new printer, you just go to the internet, you download the printer driver for that new printer, and away you go. Microsoft Word, Excel, every other program you've got on your PC knows how to access that printer. Perfect. Wonderful. So the idea is they want to duplicate that in OT. Sounds great. I mean, it's great for a paper. I mean, if you're going to write a white paper, if you're in a university and you're a professor and you want to write about how OT needs to have all of these data models for device models so that you just load those in and boom, you know how to connect to that device. Problem is, in actuality, it doesn't work. Because I was talking to another guy, and they've got injection molding machines. They've got like 16 injection molding machines. They use them completely differently. Yes, there could be an injection molding machine model, but each machine is used in a different way where they need different kinds of data out of the machine. So you can have some of the items of the model be the same across all 16 machines. Of course, there's going to be consistent data, some consistent data, but really what they need can't be captured. They have like 4 different or 5 different models on that. So all of these organizations that are building standard models, I think they're just, shooting at windmills. They're fighting windmills, and it's just not going to work. So I like the idea of modeling, but what you need to do is to be able to build the custom models for your machine and use those. That way, HiByte is a great example of a company that allows you to build really nice models. So I really give kudos to them for building that technology into their product. All right, last one. This is what I call the dirty little secret of smart manufacturing, Industry 4.0, digitalization, all of this stuff. Here's the problem with all this stuff. Is number one, if you're Procter & Gamble, if you're Exxon, if you're DuPont, if you're any one of the Fortune 100s, you can devote thousands of people, L'Oreal, you can devote thousands of people to doing IT, OT projects, and you can figure things out and know what you're doing. If you're a small guy who's running a couple of, 4 or 5 lines, and you're making some product, and you're really, number one, you're really busy. You really don't have the time to work on this. Number one, if you have the time, you can spare some time, you really don't know what to do. Okay, what are we going to do this? If you know what to do, I would like to see this this quality data, and I'd like to look at it over time and see if I can relate it to the speed of the machine or the incoming materials, all of that kind of stuff. If you know what to do, you don't know how to do it. And you don't know where to get the data. So, everybody's talking about doing Industry 4.0, and I'm on board with that. I love smart manufacturing. I love Industry 4.0. I love all that digitalization. But it's just really, really hard for the small people to know how to do that, unless they go out and they buy some consulting services. And these people, if you go on the internet, I did a survey once of 400 companies, all IT, OT kinds of companies that do this kind of work. And they are all the same thing. Well, we don't care where you are. We don't care what kind of machines you have. We don't care what kind of data we have. We're going to reach in there. We're going to suck it out, charge you $49 a month per machine, and then you're going to be able to increase the efficiency and optimize your machines way better than you do now, and you'll save. Your ROI is going to be paid back, and you're going to get 10 times the amount of value from that. I mean, it's just ridiculous to think that they know how to do that, because many people just don't know what the hell they're trying to do. I mean, digitalization is generally a case of experimentation. Try this, try to match it up to that, see what happens. It's very seldom that you know specifically, if I just had this piece of data, could figure out how to get it out of that machine, then I would know how to optimize my production processes a lot better. So as you can tell, I'm pretty worked up about all this stuff, these fallacies, these mistruths, and these conspiracies. And we're coming out with some products in the future that are going to help clear up some of this mess and help do some of these things. And I hope you'll stay tuned, and we'll be talking about it in the future. I'm John Rinaldi. This is Real Time Automation. Thanks for following me.